Hello everyone, I hope you are all doing well. So today we will be learning about mechanical properties of solids. What are mechanical properties of solids? Mechanical properties of solids are the properties which tells us how a solid will behave when different forces or different kinds of forces are applied to it, or when the solid is kept under different kinds of load. So let's say we have a solid material, or let's say we have a steel rod here. This steel rod has an original length small l and original cross-sectional area A. Now if I apply forces perpendicular to the cross-sectional area, then how will it behave? That we get to know by studying mechanical properties of solids. These properties or the concepts in this chapter will give you an idea of what will happen to the solid material when it is kept under different kinds of loads, or when different kinds of forces are applied to that solid material. So before we continue our discussion, there are some basic terms used in this chapter which you should be familiar with. First such term is stress. What is stress? So whenever we apply forces to a solid material, that solid material undergoes a change in its dimension. That dimension can be length, area or volume depending on the force. So whenever we apply force to a solid material, that solid material undergoes a change in its dimension. Now the thing is that the solid material wants to maintain its original shape and doesn't want to undergo dimension change. So what does it do? It applies a restoring force which is opposite to the applied force. It applies a restoring force opposite to the applied force. The restoring force or counter force is the same in magnitude to the applied force, but the direction of that restoring force, which you can see in yellow here, the direction of that restoring force is opposite to the applied force. So stress is defined as the ratio of restoring force and cross-sectional area. Okay, since the magnitude are same, you can also say that stress is the ratio of applied force and cross-sectional area. Now one more basic term is there which is called strain. How will we define strain? So strain is defined as the ratio of change in dimension to the original dimension. In the example which we took here, we are trying to compress the rod. So what dimension or which dimension will change? The length of the rod will change. Although the area will also change, but that is not our concern here, that we will see later. So strain is defined as the change in dimension divided by original dimension. So since we are trying to compress the rod here, the length of the rod will change. Let's say the length of the rod decreased, or the length of the rod changed by delta L. So what is the strain then? Strain is change in dimension by original dimension. So if we consider length, then change in length is delta L and original length was L. So strain in the example which we took comes out as delta L by L. Okay, so what was the stress? Stress was restoring force divided by cross-sectional area, or stress is the ratio of restoring force and cross-sectional area. And what is the strain? Strain is defined as change in dimension by original dimension. In the example which we took here, the change in dimension is length. Okay, only length will change. So strain is defined as delta L by L. So I hope the basic concepts of stress and strain are clear to you. Now we will see a law which connects both stress and strain, which is known as the Hooke's law. What do it say? Hooke's law says that if you are applying the force to a solid material in such a way that the dimension change or that deformation which is happening in the solid material is small, then for those small deformations, stress is directly proportional to strain. So if we are applying a force, or if we are applying forces to a solid material, suppose that we were applying a force of 50 Newton to any solid material, or suppose in this example we are applying a compressive force of 50 Newton to this solid material. Now what we did is that we changed the force, we increased the force. The deformations when the force applied was 50 Newton and when the force changed are small. Okay, so now what we did is that we changed or we increased the force. We increased the force in such a way that the new strain is twice of the original or the old strain. We increased the forces, we increased the compressive forces in such a way that the new strain is twice of the old strain. Then what will happen to stress? Then from Hooke's law, we know that the new stress will be twice of the old stress. This is the Hooke's law. So Hooke's law says that if you are applying forces on a solid material such that the deformations produced in that material is small, then for those small deformations, stress is directly proportional to strain. Okay. Now from exam point of view, you remember it like this, that stress, the ratio of stress and strain produced in a material, solid material, for small deformations is a constant, and this constant is called as modulus of elasticity. What's the name of this constant? Modulus of elasticity. Now different kinds of forces or different kinds of loads can be given to this solid or any solid material. So if different kinds of forces can be applied to solid material, then stress and strain can't also be of one type. So stress, strain and modulus of elasticity have three types each. Okay. Stress has, the first type of stress is longitudinal stress. The first type of stress and strain both. The first type of stress and strain are longitudinal stress and longitudinal strain. Longitudinal also has two types. First is tensile and second is compressive. In the steel rod example, our rod is under longitudinal stress. We are trying to compress the rod, or we are applying forces perpendicular to the cross section of the rod. Whenever you apply force perpendicular to the cross section of the rod, the stress developed in the material or the rod is longitudinal stress. Okay. Whenever you apply force parallel to the cross section of the rod, suppose I apply force like this. So this you can see is parallel to this cross section of the rod. So now the stress developed in this solid material will be shearing stress. Now the stress developed in this material will be called shearing stress, and the strain developed will be called shearing strain. Now if I put this solid material, or if I submerge this solid material in a fluid like water or anything, if I submerge this solid material in a fluid, then the stress developed will be called hydraulic stress and the strain developed will be called hydraulic strain. So ultimately the stress has three types, strain has three types, and modulus of elasticity also has three types. See, in case of longitudinal stress, the modulus of elasticity is called the Young's modulus. In case of longitudinal stress, this modulus of elasticity is called as Young's modulus and is denoted by Y. In shearing stress, this modulus of elasticity is called the shear modulus and is denoted as G. And when there is hydraulic stress, then this modulus of elasticity is called as the bulk modulus, which is denoted as B. So whenever the applied force on the solid material is perpendicular to the cross section of the solid material, the stress developed in the solid material is known as longitudinal stress. Longitudinal stress has two types, tensile and compressive. In the example which we took, the rod is under compressive stress. Okay. If the applied force is parallel to the cross section of the solid, then the solid material is under shearing stress and the strain, corresponding strain produced is called as shearing strain. And when our solid is submerged in a fluid, then the stress developed of the solid in the solid material is hydraulic stress and the corresponding strain produced is called hydraulic strain. Okay. So I hope the basic concepts of stress and strain are clear to you, and the modulus of elasticity also. In the case of longitudinal stress, the modulus of elasticity is Young's modulus. In the case of shearing stress, it is shear modulus, and in case of hydraulic stress, it is bulk modulus. What is Hooke's law? Hooke's law says that for small deformations, stress is directly proportional to strain. So if you change the applied force in such a way that strain doubles or triples, then the corresponding stress will also double or triple. Okay, from exam point of view, you can remember this as that stress by strain as a constant. The ratio of stress by strain is constant for small deformations. Okay, so I hope the basic concepts of stress and strain are clear to you. Now we'll see some numericals and example so that we see how to calculate this. Okay, so now let's see a numerical on whatever we have studied so far. So the question says a structural steel rod has a radius of 10 mm and a length of 1 meter. 100 kilonewton force stretches it along its length. Calculate stress, elongation and strain on the rod. Young's modulus of structural steel is 2 into 10 raised to 11 Newton per meter square. Okay, so whenever you see such question, the first thing is that you need to identify that the material mentioned in the question is under what kind of stress. Because once you identify that, then only you can use the correct modulus of elasticity. For example, if the material is under longitudinal stress, then you will be using Young's modulus. If it is under shear stress, then you will be using shear modulus. If it is under hydraulic stress, then you will be using bulk modulus. Yeah. So first of all, you need to identify that the material mentioned in the question is under what kind of stress. So here we can see that the steel rod is being stretched. If it is being stretched, then it is under tensile stress or longitudinal stress. So how will we calculate stress? So we note the definition of stress. By definition, stress is defined as restoring force divided by cross-sectional area. What is the restoring force? So if the applied force is 100 kilonewton, then the restoring force will also be 100 kilonewton. Stress is a scalar quantity, so you don't need direction here. Okay, so you can take the magnitude. So if the applied force is 100 kilonewton, then the restoring force will also be 100 kilonewton. So stress is 100 kilonewton divided by area. Area will be pi times radius squared. What's the radius here? The radius is 10 mm. Okay, so one more thing, whenever you calculate, you need to take the variables in SI units. Suppose force has a SI unit of Newton, but here we are provided with kilonewton. So we will convert this into Newton. So 100 kilonewton means 100 into 10 raised to power 3 Newton. Then pi r square. Radius is 10 mm. 1 mm is equivalent to 10 raised to minus 3 meter. So 10 mm is around, or 10 mm is 10 raised to minus 2 meter. If you square that, you will get 10 raised to power minus 4 meter square. So stress is, this area is pi times 10 raised to power minus 4 meter square. Now if you calculate this, you will get something around 3.2 into 10 raised to 8 Pascal. You can calculate and check. Newton per meter square is called Pascal. Okay, so the material or the steel rod which we are given here is being pulled, and it is producing, or it is under a stress of 3.2 into 10 raised to power 8 Pascal. Now next we need to calculate elongation. So from Hooke's law, one more thing, unless and until it is mentioned that the deformations are not small, we will always assume that the deformations are small and Hooke's law is applicable. Okay, so if Hooke's law is applicable here, then we know that the ratio of stress and strain is a constant. So stress we calculated. So stress by strain, what is the strain? Change in length by original length is a constant. And what is that constant here? Young's modulus or capital Y. Okay, so what is the elongation here? This delta L, this gives you the elongation. So if I rearrange the equation, what will I get as delta L? If I rearrange the equation, I'll get something as delta L equals stress times length upon Young's modulus. So what was the original length given? Original length was given as 1 meter. So delta L is stress, and we calculated stress as 3.2 into 10 raised to power 8 Pascal. 3.2 into 10 raised to 8 Pascal into 1 meter. And what was the Young's modulus? The Young's modulus was 2 into 10 raised to power 11. 2 multiplied by 10 raised to 11. When we'll solve this, we'll get something around 1.6 into 10 raised to power minus 3 meter. This will cancel out 1.6. Okay, So 10 raised to power minus 3 meter is mm. So this is 1 mm. So delta L is somewhere around 1.6 mm. So the change in length of the rod is 1.6 mm. The steel rod, when we applied a force 100 kilonewton on the ends of the rod, then this steel rod goes through an elongation of, or goes through a change in length of 1.6 mm. Next we need to calculate strain on the rod. What is the strain? Change in dimension by original dimension. What is the change in dimension? Here also we will take delta L in units, SI unit. SI unit is meter. So strain we will calculate as delta L by L. Delta L is 1.6 into 10 raised to power minus 3 meter, and original length is 1 meter. So the strain is 1.6 into 10 raised to power minus 3. Since strain is the ratio of two dimensions, strain is dimensionless. So here is the strain. Okay, so what we did in this question, we needed to calculate stress, elongation and strain. So by definition we calculated stress as restoring force divided by cross-sectional area, which came around 3.2 into 10 raised to power 8 Pascal. Next, we from Hooke's law we know that stress and strain, the ratio of stress and strain is a constant. So we calculated the elongation delta L. Next we needed to calculate strain. So by definition we calculated strain. Now let's see a NEET PYQ. Okay, so let's see a question which was asked in the 2018 NEET exam. The question says two wires are made of the same material and have the same volume. The first wire has a cross-sectional area A and the second wire has cross-sectional area 3A. If the length of the first wire is increased by delta L on applying a force F, how much force is needed to stretch the second wire by the same amount? So first of all, if two wires are made of the same material, then that means the modulus of elasticity of both the wires are same. The modulus of elasticity depends on the solid material. So if both wires are made of the same material, then the modulus of elasticity of both the wires will be same. So first of all, we need to see what kind of stress the material is under. So if you read the question properly, it is written that we are stretching the material. So if we are stretching the material, then the material is under longitudinal stress. So what will be the modulus of elasticity? Young's modulus. So from Hooke's law, we know that stress upon strain equals Young's modulus. So we have two wires. So what we will do is we will name them as F1A1, delta L1, L1. So this is constant, Young's modulus, and this constant is equal for both the wires. So we can write this as F2 by A2 equals delta L2 by L2. Now it is also given that delta L is same for both. So if delta L is same for both, so this is actually delta L. We can name this as delta L. Now if this is my equation 1, if this is my equation 1 and this is my equation 2, if I divide both equations, now if I divide or equate both equations 1 and 2, I'll get something like this equals F2 upon A2 L upon L2. So this delta L I can cancel from both sides. So I'll get something like this F1 cross L1 by A1 equals F2 cross L2 by A2. Now the thing is that L1 and L2 are original length and we are not provided with the original length. Instead we are provided with the volume. What is volume? So area times length is volume. So what we need to do is we need to introduce volume in our equation and eliminate or remove length from our equation. How can we do that? So if I multiply area in both numerator and denominator like this, then area times length is volume. So I can remove length from my equation and bring volume into my equation. So then how will it look? It will look something like this. F1 into volume divided by A1 square equals F2 into volume divided by A2 square. Now I can cancel volume from both the sides. If I cancel volume from both the sides, what do I want? I want F2 because F1 I know. So how will I find F2? So F1 times A2 square divided by A1 square will give me F2. And what is F2? Sorry, what is F1? F1 is given as F A2 square. A2 was given as 3A square, and A1 was given as A. So A square equals F2. If you solve this, you can see that we'll get F2 as 9F. Okay, so the answer to our question will be 9F. That means option A.